Hi folks, Mr. Long here. I'm going to do a quick screencast for antiderivatives. So specifically what we're looking at today is antiderivatives that have this form over here. A times x to the n dx, the integral of ax to the n dx in the antiderivative of that. So one of the things that we always do is we take that coefficient of a and we bring it outside. So it becomes a integral or antiderivative of x to the n dx. And then our formula is x to the n becomes x to the n plus 1, all divided by n plus 1 plus some constant of integration c. That's the formula. So let's go through this specific example. So the first thing I need to do here is I need to take the 5 and remove it outside. It's a coefficient, remove it outside. The second thing I need to do is to write this as a rational exponent. So that's 4, that's 3, so it's 4 over 3. Why is it negative? It's negative because it's in the denominator and involves division. Okay, so first thing I have to do with questions like this is I need to write them in this way. Okay, so I have to get rid of the radical symbol and write it as a fractional or rational exponent. Then I still haven't done any calculus. That's just simplifying. Okay, the next step I do calculus. I have to add 1 to the exponent. So I've got negative 4 over 3. I need to add 1. Of course, I'm going to represent 1 with 3 over 3 because I've got thirds here. Negative 4 over 3 plus 3 over 3 is negative 1 over 3. So I divide by that negative 1 over 3. Notice you have n plus 1 here and n plus 1 here. When I simplify, negative 4 thirds plus 3 thirds is negative 1 third. And then I have 5 divided by negative 1 third. Well, 5 divided by negative 1 third, you multiply by the reciprocal. So that becomes negative 3 over 1 times 5. That's negative 15. Okay, and then finally, I have negative exponents. I put it in the bottom. Now, as a last step, what I could do is I could write that as negative 15 over the cube root of x plus c. But I don't, for me, you don't have to worry about that. Okay? All right, that's it, folks.